We have an example problem here. Radiation from the sun reaches the Earth above the atmosphere at an intensity of about 1350 watts per meter squared. Assume that this is a single electromagnetic wave and calculate the maximum value of the magnetic field. Intensity I, or S average, is approximately 1350 watts per meter squared. And that's before it goes through the atmosphere. The atmosphere absorbs some of that energy. So the sun is emitting light in all directions. This intensity is at a distance of where Earth is. Okay, this intensity would be the power of the sun divided by the 4 pi r squared, where r was the distance from the sun to the Earth. It turns out we don't need that particular information, though we could work backwards and find the approximate power of the sun if we wanted to. They're asking us to calculate the maximum value of the magnetic field. So intensity, or S average, in terms of electric field, at least in terms of our equation given in the test notes, they give it to us in terms of the maximum electric field. So E naught represents the maximum electric field value. It could also be representing, it's the same thing, just different words. The amplitude of the electric field, the peak value of the electric field. They want, as far as this question is concerned, they want the peak or maximum value of the magnetic field. So we need the relationship that c, the speed of light, is equal to the maximum electric field over the maximum magnetic field. Now we could find E naught, the numerical value, and then plug it into this equation, or we can plug this equation in symbolically. I don't know that one way is any particularly better than the other per se. So E naught is C times B naught, but that needs to be squared. So 1 over 2 C mu naught times C squared B naught squared. So this intensity, or S average, would be C B naught squared over 2 mu naught. Because one of the C's here will cancel. All right, so B naught, the maximum value of the magnetic field, 2 mu naught I over C. Mu naught, I remember the exact value. You can pull the value out of the chapter. I is the intensity, not a current, which my brain really wanted to think current there. C is the speed of light, which we have. So plugging these values in, I'm going to get scientific mode so I don't have to count zeros. 3.36 times 10 to the negative 6. Magnetic fields are in Teslas. I trust that when I know I'm putting everything, all the numbers in terms of SI units. We can use the table on page 3 of our test notes to make sure it's working out in terms of all the units. But Let me know if you want me to do that. I'll send that working out to you if you'd like. So intensity, always related to power of the source and how far away from the source we're talking about, but also related to electric field and magnetic field we're seeing here, because E and B are always related.